In this video, we'll be looking at operations on sets. Before I continue, I would like you to subscribe to this YouTube channel and hit the notification bell to get updated for upcoming videos. From our previous videos, we've treated introduction in set, where we define some terms that we felt would be very important when dealing with sets. So now we'll be looking at operations on set. The first operation, there are several operations involving sets. The first one I would like us to look at is union of sets. When we are talking about union of a set, we are talking about joining. From the word union, when you hear union, joining of the element that is in a particular set with the element in another set without repetition. All I'm trying to say that the union of a given set A and B is the set which consists of elements that are either in A or B or both without repetition of elements. The union of a set is usually denoted as U, capital U. For example, if you want to write the union of set A and set B, is usually written as A union B. Now I want us to look at examples. Let's say we are given the sets A. Our set A, we are giving it to be A, B, C, D, and set B is given as 1, 2, 3, 4, and set C is given as A, B, C, E. Now we are asked to find 1, A union B, 2, B union C, and 3, A union B union C. Now solution, let's do our solution here. From what I said earlier, you just have to join the elements that are in both sets. Now number 1, we're asked to find A union B. So we have set A. What are the elements in A? Check. And also check for the elements in B. Now here we have elements of A to be A, B, C, D. Element of B is 1, 2, 3, 4. So in this case, you just have to join the elements together. That means our A union B will be equal to A, B, C, D. Then we have 1, 2, 3, 4. Now assuming our set A and set B has something in common, maybe set A has 3 as one of its elements, you just have to pick one of it. So we just have to pick one of the 3 and apply it. Okay, so the next one we are asked to find B union C. So we have to look at our elements in B and the elements in set C. There's nothing in common, so you also write A, B, C, E. Then we also have 1, 2, 3, 4. So this is it. The last one, we're asked to find the union of the 3. The union of the 3. Now, if you check set A and set C, there is something in common. Set A has ABC, set C also have ABC. Now, the fact that these two have the same element in common does not mean we are repeating them. We are not going to say A, B, C, C. No, we just have to pick one of them. We say A, B, C, This is it. Then we continue D, then E, then we go to element B now. We have 1, 2, 3, 4. Most times it is usually advisable to write the alphabet first before writing the numbers. Okay, let me add one more. Let's say we are asked to find the union of, let's do A union C. Okay, so we have A union C. Now looking at this, they both have something in common. That does not mean you repeat them. That does not mean you repeat them. So we have A comma B comma C, then we have D comma E. So this is as simple as ABC. Just join the elements that are in both sets together without repeating of any element. The number 2 set operation we have here is what we call the intersection of sets. When we are talking about intersection of sets, we are only trying to say, look at the two or more given sets. You are asked to find their intersect and do what? You pick what is common. You look at set A for instance and set B. Check, what does set A have that set B also have? That is simply the intersection of any given set. It is usually denoted as small letter n, or you can also say upside down U, but it's usually denoted as small letter n. For example, if you are asked to find this set of the intersection of two given set, let's say set A, between set A and set B. So we say A intersection B. That's how it is simply written as. Let's look at an example. We are giving, let set A be given as 1, 2, 3, 4, 5, 6, 7 and 8. And let set B be given as 2, 4, 5, 7. Now we are asked to find A intersection B. We don't know it. Okay, like I said earlier, look at the two given sets. What do they have in common? Okay, looking at set A, looking at set B, we observe that their intercepts, which is this, both A and B has 2. Yes. What else again? There's no 3 in common. The next one is 4, then 5 and 7. So this is what the intercept of a given set implies. Just look at what they have in common and what you pick them out. That's all. The third operation I would like us to look at is what we call disjoint of sets. From the word disjoint, they are not joined together. They have nothing in common. They are separated. So when we are talking about the disjoint of two sets are said to be disjoint if they have no element in common. They have nothing in common. For instance, let's say we have a given set A. Let's not use A this time. A given set B to be 1, 2, 3, 4, and the given set C to be A, B, C, D. Now, the disjoint of these two given sets is when they have nothing in common. That means the intersection of the two sets is what? Is nothing. Is a null set, or is a null set. That's an empty set. An empty set is a null set, and is usually represented with curly braces, two curly braces with nothing inside, or we use this other symbol phi to represent it. So disjoint of a set is also very easy to understand. When they have nothing in common, we call it the disjoint of two sets. So the fourth operation on sets is what we call complement of a set. From our previous videos, we've already have the understanding of what we call the universal set and the meaning of a subset. So let's say we have a universal set. We have a universal set and a subset A. So this is our universal set. Universal set and a subset A. Now when we are talking about the complement, let's say we are asked to look for the complement of the subset A. The complement of A is usually written as A prime. We say A prime or A complement. So this is representing complement of A. Now it actually means the set of all elements that are in the universal set that are not in set A. Let's look at this example. Let's say we are given let's say our universal set is given as, now this is a set using a rule, okay, and we are given set A to be 1, 2 and 3, and set B to be 2, 4, 6. Okay, this is a set of even numbers. Now we are asked to find one A prime, which is A complement. We are asked to find B complement also. We are also asked to find this is the third one, I. We are asked to find, let's say, A union B complement. And then the last one, IV, we are asked to find A intersection B complement. Sorry, let's say the complement is out. So this is solution. The first one is A complement. Now when we are asked to find the complement of a given set, they are only saying check the universal set, check the given set. What is in the universal set that is not in the given set? So now let's first simplify our universal set because it was given to us as a rule, and I explained this. Now it's having less than or equal to, meaning x is starting from 0 ending at 10 because of the equality sign. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So now our A complement will be, sorry, let's just say this is A, not complement of A. A is 1, 2 and 3. Okay, so these are A complement. Now will be what is in the universal set that is not in A. Looking at it, A does not have 0, A has 1, A has 2, A has 3, A does not have 4, 5, 6, 7, 8, 9 and 10. So this is A complement. The same thing goes for B. our B element, our set B was giving us 2, 4, 6, 8 and 10. Now B complement will be giving us, using the universal set we have there, our B complement will be giving us what is in the universal set that is not in B. We have 0, B does not have 0, B does not have 1, B has 2, it has no 3, it has 4, it has no 5. So B is a set of even numbers. So every even number apart from every even number is in set B. So what we have will be odd numbers as the complement of B. So we have 0, 1, 3, 5, 7 and 9. Okay, so the third one, what we're asked to find, the complement of the union A union B complements. First, let's look at what A union B is. I've explained earlier that A union B means join the two elements in A and B without repetition. So we have 1, 2, 3, 4, 6, 8 and 10. Right? Okay. So our A union B complement now will be what is in the universal set that is not in A union B. Okay, so we have 0 is not in A union B, there is no 5, there is no 7 and there is no 9. So this is A union B complement. And then the last one is A intersection B all complements. Now A intersection B, firstly, what does A and B have in common? Looking at it, A and B has 2 in common. So we look at the complement of A intersection B. And the complement of A intersection B is what is in the universal set that is not in A intersection B. We have 0, 1, there is 2, there is no 3, 4, let's continue it here, 5, 6, 7, 8, 9 and 10. So this is it for complement of a set. Now lastly, we are going to look at difference of two sets. This is the last operation of set I would love us to look at. We are all familiar with the term difference. When you hear difference, you're talking about subtraction or minus. Yes. The same way we subtract from our we subtract our numbers, we also do subtraction of sets. That does not mean you are exactly subtracting each element from the other element, but what this simply means that when you are given a set A and another set B and you are asked to find the difference between the two sets, you are simply asked to check what is in the first set that is not in the second set. Well, it depends on how the question looks like. Okay, let's look at this example. Let's say we are given set A. Let's not use set A, let's say set S to be 1, 4, 5, 6, 7 and 9, and our set T is giving us 1, 2, 3 and 4. Now let's say we are asked to find 1. Oh, this should be 1. We are asked to find 1 S minus T. Then 2, we are asked to find T minus S. Now the solution to this is very simple. So we have the first one, S minus T. From the given set, check what are the elements in S that are not in T. You are removing the elements that are in T from S. Now looking at it, if you check S, you see that there is 1. T has 1. Good. Okay, so you check S has 4 but T does not. T also has 4. Good. Now S has 5, T does not have 5. So we have 5. That is an element that is in S that is not in T. We have 5, 6, 7 and 9. This is actually the difference between S and T. That's S minus T. Now let's see when we are giving T minus S. How will it look like? When you are giving T minus S, we are actually saying what are the elements you can find in T that are not in S. Looking at T, we have element 1, 2, 3, 4. Now T has 1, S has 1. That's nice. That means 1 is not part of the answer. Now look at T. T has 2 but S does not have 2. So we have 2. T has 3, S have no 3. So 3. So the difference here, T minus X is 2, 3. Very simple. So the operations of set, we have looked at the union of a set, intersection of two sets, disjoint of a set, complement of a set, and here we have difference of two sets. Thank you for watching this YouTube channel, and please do not forget to click the notification bell to get updated for upcoming videos.